All right, so this is the beginning of Chapter 6 and specifically Section 6.1. In Chapter 6, we're going to talk about solving system of equations in a few different ways. And in 6.1, we're only going to focus on one method, and that's through graphing. All right, so our goals or objectives for today, what we want to accomplish in these videos, is to solve system of equations by graphing. All right, that's the first one. That's what this first video is going to be about. And then the second video is we're going to analyze special systems. All right, so there's certain times where systems can be all real numbers or infinitely many solutions, and there's times where they can have no solutions, and we're going to analyze those as well. All right, so for this video, first off, what is a system of equations? So two or more linear equations form a system of linear equations. What exactly is that? So if I tell you y is equal to x plus 1 and y is equal to 2x minus 1. All right, so I just created these two equations. If I tell you that the same x and y that satisfy this equation have to satisfy this, then that means it's a system of equations. So it's where we're looking for an x and y value that satisfy multiple linear equations at the same time, or multiple equations at the same time. So in this case, if x is equal to 2, and y is equal to 3, if we substitute them in both, 2 plus 1 is 3, so we know that it works for this equation, and then 2 times 2 is 4, minus 1 is also 3. So this would be our solution to this system of equations, where the x and y has to satisfy both at the same time. All right, and we're going to learn different methods of solving for it, and today is just going to be through graphing. And just like I was just saying, any ordered pair that makes all of the equations in the system true is a solution of the system of equations. So for this system of equations I drew over here, our solution will be x is equal to 2 and y is equal to 3. This will satisfy both at the same time. And for this essential understanding, we're going to go over in class together, but we can use systems of linear equations to model problems. So just like we've done in the past where we've come up with equations based on word problems, we can do that with a system as well, where we can generate two equations and look to satisfy them both at the same time. All right, so now in this section, there's going to be two questions that we're going to do. All right, so we're going to solve this system of equations that we have here, meaning that the same x and y value that satisfy one of the equations have to satisfy both in order for it to be our solution. And our method that we're doing for this one is by graphing. All right, so I'm going to first graph these two equations. So the first equation I'm going to graph is y is equal to x plus 2, and I'm going to graph it in red. All right, remember, we have our slope-intercept formula. So in this example, we know that our b, or our y-intercept, is 2, and our slope is equal to 1. So that means quickly I could start off at 2, and then my slope is up 1 over 1, up 1 over 1, up 1 over 1, down 1. All right, so I know that quickly this is my graph of the red equation. All right, so that means any point that I pick on this red equation will satisfy this equation that we have here. So for instance, if I pick this point of 4, 6, well, when we plug this in, 6 is equal to 4 plus 2. Yes, 6 is equal to 6. So any point that we pick on this red line satisfies this equation. The second equation, y is equal to 3x minus 2, I'm going to do in blue. So same thing, we know y is equal to mx plus b. So my slope is equal to 3, and my b is equal to negative 2. So that means my y-intercept is down here at negative 2, and my slope is up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. All right, so I know that this is the graph of my blue equation. Right, you guys would use a ruler in class, so you guys would be able to draw a little bit clearer. It's a little bit hard for me to draw straight lines on this. All right, now, once again, any point I pick on this blue equation will satisfy, this blue line will satisfy the blue equation. So let's just pick this point here of 1, 1. So since we plug it in, does 1 equal to 3 times 1 minus 2? Well, does 1 equal to 3 minus 2? And 1 does equal to 1. So any point we pick on the blue line satisfies the blue equation. So what that means then is where these two graphs overlap tells me the solution that they both share. So this is where they intersect. So that means that this point here has to satisfy both the red equation because it's part of the red line that we have, and the blue equation because it's part of the blue line that we have. And that point intersects at the point 2, 4, so that means x is equal to 2 and y is equal to 4. So we can check this out by plugging them in. So for our red equation, does 4 equal to 2 plus 2? And yes, it does. So we know that it works for our red one. And then for our blue equation, does 4 equal to 3 times 2 minus 2? Well, 4, does that equal to 6 minus 2? And 4 does equal to 4, check. So we know that it worked for both. So that is a solution of this system of equations. All right, that is the only example that we're going to go through in this video. So if you have any questions, make sure that you ask them and we can go through it together in class.